Somewhere in the Pacific, a steel tube the length of 2 football fields is moving through complete darkness at 800 feet below the surface. The crew inside cannot see sunlight, call home, or surface for help. They have been down there for weeks and will stay down for weeks more. This is not punishment. It is the normal life of a nuclear submarine. There are roughly 70 nuclear submarines operating in the world at any given moment, and the United States alone operates 68 of them. Each is a self-contained world where more than 130 people eat, sleep, work, and sometimes quietly unravel, all without seeing the sky. Understanding what happens inside one means understanding a machine, a habitat, and a military system at the same time. The hull is the first thing to understand. A Virginia-class submarine is built from high-strength steel, roughly 2 inches thick. It is designed to withstand pressures that would crush a car engine almost instantly. At test depth, estimated around 1,600 feet, the pressure outside is about 50 times atmospheric pressure at sea level. The hull does not flex much, it holds. But it makes strange sounds, groans, pops, and settling noises that new crew members often mistake for failure. Veterans learn to sleep through them. There are no windows, not one. Submariners navigate entirely by instruments, watching numbers on screens rather than any external horizon. After a couple of weeks, many report that the outside world starts to feel abstract and time becomes unreliable. To help, the Navy uses artificial lighting that cycles through a simulated day, though the cycle may have little to do with the weather or daylight above. Life aboard runs on an 18-hour schedule rather than a normal 24-hour day. Crew members stand 6 hours on watch, 6 hours off, and 6 hours for sleep. That rotation repeats for the entire deployment, so the internal calendar quickly drifts away from the one on land. Monday and Friday become nearly meaningless. The watch never stops. That schedule is one reason submarines feel so strange to people who have never lived on one. The day is not just shortened, it is reorganized around function. People wake, work, eat, and sleep according to the needs of the boat, not the sun. The result is a living system in which the crew and the machine set the terms of time. The control room is the operational heart of the submarine. It is about the size of a small apartment and packed with sonar displays, navigation equipment, periscopes, and controls. The officer of the deck stands for the entire 6-hour watch, because alertness matters too much for comfort. Sonar is the crew's only real connection to the outside. Active sonar is rarely used because it reveals the submarine's position. Passive sonar simply listens, and the operators build a picture of the ocean from sound alone. Ships, whales, storms, geology, and distant propeller noise. That listening culture is central to submarine warfare. The boat wins by hearing first, understanding first, and staying hidden while everyone else makes noise. A good sonar team can identify a ship class from the rhythm of its screws or distinguish a merchant ship from a warship by the way the machinery resonates through the water. The ocean becomes a text to be read. Communication with the surface is tightly constrained. Ordinary radio waves do not travel through seawater, so the Navy uses extremely low-frequency transmitters on shore. Those signals carry only tiny amounts of data, sometimes at about a character per second. Personal contact is handled through screened messages from home called familygrams, usually only a few dozen words long. A sailor may receive one each week and may not be able to answer directly until the submarine surfaces or returns to port. Bad news is handled carefully. If a sailor's family member dies during patrol, the commanding officer decides when and how to tell them based on the situation and the sailor's welfare. The submarine cannot simply stop. The patrol continues, the machinery keeps running, and the crew around that sailor does what it can. At the aft end of the submarine sits the reactor, sealed behind bulkheads. On a Virginia-class boat, it is a pressurized water reactor generating about 40,000 shaft horsepower. It requires no air, produces no air, and can run for roughly 33 years without refueling. The reactor heats water under high pressure. That heat makes steam, the steam drives turbines, and the turbines drive generators and the propeller shaft. Most crew members never see the core. They interact with gauges, readouts, and reactor operators who monitor every variable. The reactor is the reason the submarine can stay hidden so long. A conventional diesel boat would have to snorkel or surface to breathe air and recharge batteries. A nuclear boat does not. That gives it the endurance to patrol across oceans and remain submerged for weeks, which is what makes it such a strategic problem for adversaries. If the boat is not seen, it is not easily hunted. The submarine must also manufacture its own atmosphere. An electrolytic oxygen generator splits seawater into oxygen and hydrogen using reactor power. The oxygen is fed into the boat. The hydrogen is vented overboard. Carbon dioxide from 130 people is scrubbed by chemical systems that absorb it and release it later when heated. If those systems fail, there are emergency oxygen candles that release oxygen when ignited. The air inside is constantly being made, cleaned, and monitored. Atmosphere control is more than comfort. A submarine's internal environment has to stay within tight limits because the crew can't step outside for fresh air. Humidity, carbon dioxide, temperature, and contaminants all have to be managed while the boat remains closed up for long periods. The life support plant is therefore as essential as the reactor itself. Fresh water is produced on board as well. Heat from the reactor powers a distillation plant that evaporates seawater and condenses it into pure water. The submarine can make several thousand gallons per day, enough for drinking, cooking, and very limited showers. Water is treated carefully. A submariner may get only a couple of minutes under the shower, and using more than that is a social offense. Food matters enormously for morale. Submarine crews are fed better than almost any other branch of the military. Early in a patrol, the refrigerators are full and meals are ambitious. As weeks pass, fresh food disappears and the menu shifts to frozen and then canned goods. Morale drops as the food supply shrinks and the crew feels it directly. That is why the cook often becomes one of the most important people on the boat. Good food breaks the monotony, anchors the day, and gives the crew a reason to gather in a space that is not purely operational. In a closed environment, meals are more than calories. They are a small form of social stability. Space is tight, so hot racking is common. 2 sailors share one bunk on alternating schedules. When one goes on watch, the other climbs into the warm bunk. Personal storage is tiny. Nearly every surface is occupied by equipment, bunks, or gear tied down so it will not move. The boat smells of oil, machinery, recycled air, and food. After a long deployment, many submariners say stepping onto land feels overwhelming because fresh air itself seems unfamiliar. That cramped layout is the cost of putting an entire power plant, weapons system, and crew habitat inside one pressure hull. Every cubic foot is contested. If something gets bigger, something else has to get smaller. The submarine's engineering is therefore a constant negotiation between comfort, capability, and survivability. Nuclear submarines come in 2 broad categories. Fast attack submarines hunt enemy submarines and ships, gather intelligence, and conduct covert operations. Ballistic missile submarines, by contrast, carry nuclear weapons. A single Ohio-class submarine can carry 24 Trident II missiles, each with multiple independently targeted warheads. One fully armed boat carries more destructive power than all the weapons used in World War II combined. The launch system is built around the 2-person rule. No single person can arm or launch a nuclear weapon. Every step requires 2 authorized people to act together and confirm the order independently. The launch order itself would come through an extremely low-frequency communication channel and would be authenticated with physical keys and sealed instructions carried aboard. Those orders are rehearsed regularly, even though the crew never hopes to use them. The point of a ballistic missile submarine is deterrence. It must remain hidden, ready, and capable of retaliation even if the country above has already been hit. That means crew members may be operating with no direct knowledge of what is happening on land, and sometimes with families in cities that no longer exist. The submarine keeps patrolling because the logic of deterrence depends on it. The Navy screens submarine personnel intensely and continues monitoring them throughout deployment. Psychological reliability matters. The Personnel Reliability Program can remove someone from nuclear duties if they show signs of instability. But the signs are usually ordinary. Not eating, sleeping too much, withdrawing from the crew, or failing to participate in the rituals that hold the boat together. Noise discipline is another defining part of life. Fast attack submarines on quiet missions try to make almost no sound. Voices stay low. Shoes are soft. Hatches are closed slowly. Tools are set down rather than dropped. The cook avoids unnecessary fans. The whole crew becomes a collective silence machine because sound is the submarine's most dangerous giveaway. That silence is not just etiquette, it is a tactical weapon. Every pump, motor, and moving person can produce acoustic clues that an enemy sonar system might detect. The submarine therefore treats sound as a form of exposure. It is one of the few military machines where being quieter is often more important than being faster. When a sonar operator hears something, the team starts target motion analysis. They do not use active sonar if they can avoid it. They listen, mark bearings, and use geometry over time to figure out range and course. That process can take hours or days. During the Cold War, American and Soviet submarines shadowed one another this way in the North Atlantic and Pacific, sometimes within a few hundred feet of each other in total darkness. There were collisions. In 1992, the USS Baton Rouge collided with a Russian Sierra-class submarine off the Kola Peninsula. The ocean floor still holds the evidence of how close those patrols sometimes came. The first nuclear submarine, USS Nautilus, proved the concept in 1954 and later made the first submerged voyage to the North Pole. Since then, submarine technology has advanced, but the basic bargain remains the same: stay submerged for weeks, hidden from the world, and keep the reactor, air, water, food, and weapon systems functioning in a steel tube under pressure. The danger is real. The Cold War lost two nuclear submarines, USS Thresher in 1963 and USS Scorpion in 1968. Both losses reshaped safety procedures. Modern boats now carry rescue systems such as pressurized escape modules and deep submergence rescue vehicles. But even today, rescue is a race against time. If a submarine is in deep trouble, help is always hours away. The daily work aboard a submarine is deliberately repetitive because repetition keeps the crew sharp. Watches change, logs are updated, equipment is checked, and meals arrive in a predictable rhythm. The routine is not boring by accident. It is designed to keep a small group of people functioning inside a metal tube where lapses can become serious very quickly. Life aboard is organized around small routines that keep people sane. The crew shares meals, watches movies, plays cards, and creates small rituals to resist the strain of confinement. The galley becomes one of the most important places on the boat because food is morale. The medic is equally important because the nearest hospital may be far away. A submarine medic is trained to handle everything from fractures to cardiac events until a helicopter can arrive. The social life of a submarine is deliberately small because it has to be. Crews need enough variety to stay mentally sharp, but not so much clutter that the boat becomes disorganized. People learn each other's habits quickly. A slight change in tone, posture, or appetite can matter because everyone lives in such close quarters. At the end of a long patrol, the crew surfaces, enters port, and walks into sunlight after 90 days underwater. The world above has moved on. Children have grown, seasons have changed, and the submarine crew steps back into a life that suddenly feels loud and wide. Most adapt within weeks, then begin the cycle again. The strategic value of all this is straightforward. Nuclear submarines are the most survivable part of the nuclear deterrent. Land-based missiles can be targeted, bombers can be tracked. A submarine running silently at depth is far harder to find. As long as it remains at sea, it guarantees retaliation. That survivability is the reason the boat exists at all. The whole design is built to stay hidden, stay alive, and remain useful even when everything around it changes. Automation is now starting to change parts of the job. Several countries run highly automated submarine support systems, and some rail-style autonomy concepts in other industries have inspired naval thinking. But on the submarine itself, the human crew still matters. Sensors can detect a lot, but they cannot replace judgment, improvisation, or the ability to notice what does not fit the pattern. That tension between machine and crew is what defines the modern nuclear submarine. It is one of the most complex engineered environments on Earth, operating under pressure, in silence, with a reactor, a life support system, a weapons system, and a crew all depending on one another. The world above sees only a shadow in the ocean. Inside that shadow are 130 people, a reactor, a control room, and a machine that can stay underwater for months at a time without surfacing. The technology is extraordinary, but the human discipline behind it is what makes it work. Submarine design has always been a balance between endurance and vulnerability. A boat can stay hidden for long periods, but it cannot ignore maintenance forever. Hull coatings, valves, pumps, sonar arrays, and reactor systems all need careful inspection when the boat returns to port. The quiet life below the waves depends on an enormous amount of work above them.